Hey folks, back again with another session of F# live coding. Today, oh no, let me take a step back. Yesterday I did a stream and it failed miserably because my settings in OBS were like super heavyweight, and then I had the new Visual Studio installed. It's where I do most of my F# programming, and the combination proved to be lethal for my CPU, so my stream was crashing and my Visual Studio was crashing at the same time. So I'm just gonna start again, or rather I'm not gonna start again, but I'm gonna pick up where I left off yesterday. So this will be a bit weird, jumping in the middle of a coding project, but it's just an hour of work. Let's quickly go over it. The goal of this series is to explore F#6 and .NET 6 and the new Visual Studio, play around with things a bit, to see what improved, because Visual Studio has really good C# support, and it has somewhat less than stellar F# support, and I want to see if things improved in this release. And what better way to check it out than to program some actual code, or to write some actual code. So what are we building? Let me drop to the screen. We are building an app that will help me figure out how many hours I spend playing video games. We will be using two online services. One is called Groovy. So let me quickly go to the Groovy website, and it's a game tracker. So I have several shelves here, my backlog of games I want to play, a wish list of games I am interested in, games I'm currently playing, which are Caligula Effect 2 and Ninja Gaiden Sigma. Ninja Gaiden is hard as balls. I mean, I play Dark Souls, I play Sekiro, no problem, but Ninja Gaiden, I get whooped. But anyway, there's this most important shelf for the question I'm trying to answer is this played shelf. This contains all the games I played in recent years, and I want to have that serve as the input. So then I know, okay, these are all the games I've played, and then I would like to convert that list or that library into a guesstimate or a rough estimate of how many hours I actually spent playing all these games. And for that, I was looking around, and one of the better websites to figure out how long a game typically takes, so not my personal time, but how long a game typically plays by all players worldwide, is called How Long to Beat. It's this website, and it lists like for different game styles of different styles of players how long they took to finish a game. So I will be combining these two sites, the list of games I've played on Groovy, to get like my shelves, and I will be using How Long to Beat to put a number on it, and hopefully at the end of this series we'll have an answer to the question how many hours we played games for. We'll be using some idiomatic F# stuff like type providers, or I don't really mean idiomatic, I mean some stuff that is pretty unique to F# actually. I haven't seen it in another programming language, so that might be interesting to play around with. And also, of course, the new .NET stuff. I don't think much has changed for F#6 specifically, or at least not for my needs. But yeah, we'll see. So what did I do previous time? And this will be a quick flyby. I did the first part, so the building my shelf of played games. And the way I did that is in that Groovy website. I showed you this one. There's a button somewhere in my profile to export my collection to a CSV file. Did that. Let's quickly open it. I hope it won't open. Okay. So it's a CSV file containing all the games in my collection, and whether I played it, I backlogged it, or I finished it. And yeah, some other metadata, but that's actually all we need. And we wrote a parser last time to parse the CSV. So this is the parsing logic. It's 30 lines of code, so it's not that difficult. And we use a C# specific thing called type providers. And long story short, these two lines, we point like this CSV provider to the CSV file itself. And this thing generates a strongly typed way of manipulating or at least reading that CSV file. So if you look at this function here, parse file, we just provided a path, and then we use that generate type, the Groovy CSV thing, to load that file. And if you look at what we do with every row in that file, so we map over the rows here, you see that we have this Groovy CSV.row type. And if you look at the properties it has date, developers, franchises, genres. So actually this CSV provider generates the types based on the headers of the CSV file. So we can access the data in a CSV in a somewhat strongly typed way without having to write any types ourselves, which is pretty cool. There's some rough parsing after, because one of the columns we need, like which shelf the game belongs to, the column was actually a column containing a JSON object. Yeah, this one. It was a bit crazy, but never mind that. It works. Let me show you that it works by opening a REPL. So this is doing exactly the same. We're reading the file and we're parsing it. Let's quickly execute that in F# interactive. First time always takes a while to boot up. And there we go. We can read the file, and the thing we have is a list of Groovy games, and a Groovy game for now is just a title, so the title of the game, and the category, or the category is actually a bad name now that I think about it. It should be like shelf. Let's quickly fix that. Shelf with the F? Yeah, shelf. That should still work. I'm also building or not just writing some F# scripts, but I'm building an actual application, like a .exe. I don't do that very much when I hack together stuff with F#, so it was something new for me. Okay, it still works, and we have shelves now. Just gonna quickly commit it. There we go. I'm thinking, should we write some tests for this to go over how I typically unit test F# code? Or should we just drop to the next thing, which is looking up the playtime on how long to beat? I feel like writing some tests first. Let's spend 10 minutes maybe writing some tests for the thing. What I like to do when I write unit tests is keep them super fast. And the way you keep tests super fast, or typically the way I keep them fast, is by not doing any actual I/O in my tests. So I do everything except the I/O part. And in this case, that would mean doing everything except reading the actual file from disk. So strategy I'm thinking about is just having a string in my tests that contains some of the data for the CSV file, and see if we can parse that correctly. So yeah, let's give it a try. I'm using XUnit and Unquote. Unquote is something I only see people use in F#, but XUnit is the thing you see in C# code bases as well. I'm going to be using that here as well. One fun difference, between C# and F#, or at least the usage of XUnit, is in XUnit, no. In C# you need classes and methods, and then you need to add an attribute to those methods. In F# you can actually skip that step. Now that I think about it, maybe in the C#6 changes you could also skip that step. But that's for another session, for another stream. In F# at least, you can just write a top-level function, or a function inside this test module I declared, and add the attribute there, and that's all you need. So that's a bit less heavyweight and gets straight to the point. You can group tests in different files or in different modules. It's of course still possible. But I like this somewhat minimalist approach on writing tests. So let's write some tests for Groovy, or parsing of Groovy CSV file. I'm just gonna declare a new module to group all those tests together. I think I need an equal signs here. Let's just give it a try. Also a cool thing about F# is your function names can have spaces in them if you use these backticks. So if you write a unit test name, or if you write a function that contains a test, you can just type English sentences and you will see them in your Azure DevOps or whatever in your test runs. You will just be able to read English sentences instead of these like weird underscore or camel case methods you typically see in C# code bases. So let's see if we can parse this basic Groovy CSV. So let's first grab some basic Groovy CSV. We'll have to do some small redesign on the code because I haven't cleanly separated the IO part and the parsing part yet. So we'll do that in a second. Let's maybe grab 2. No, let's just grab 1. So I'm grabbing the headers and a single line. So this would be a very small Groovy file, but it's good enough for a simple test. Let's put that in a string somewhere. So again, I don't like reading files when I run my tests because every millisecond counts, especially if you do like run your tests on save or run your tests on build. If every millisecond is a millisecond too much. So let's just see what this gives us. Oh no, there's double quotes in there. How do you do that again? How do you do that again? Is it double quote? I forgot. Let's just escape our quotes inside the string. So whenever we encounter double quotes, escape it. I think that should be identical. And now let's look at the code and see how we can split this up. So the actual function we'll be testing is this or something that will resemble this. Right now we provided a path to the file. So this line does the IO and reads the actual file on the disk. And I would like to not do that in my tests. So I'm just gonna write this function again, or make a new function at least, which is almost the same, but instead of providing a path, we give it the contents itself. Is it a good idea to have a string as input? Groovy file will never be too big. I think we'll get away with a string. Let's look at what we can do with this type provider. We can give it a... Oh wait, I think there's even... We can do .load to load a file, but I think there is a parse. Oh, there is there is a parse function. Actually, it's simpler than I thought. It's basically just parsing these contents, probably. Okay, these are similar enough and they're close enough to not clean up any further. There's a bit of duplication there, but it's minimal. So I am comfortable just testing the parse contents thing, and assuming that the parse file will probably work as well. My unit tests never cover everything or every side effect, at least not every side effect related to IO. But let's give this a try, and then we can immediately see unquote in action as well. Or maybe let's show unquote first. It's a really cool testing or assertion library. Why is it a cool assertion library? So when everything's green, there's no difference between this and the standard XUnit assertions, but let's introduce a bug here. So 1 plus 2 plus 3 equals 6. But what if we have a bug somewhere in our code? So this should fail, and it will fail, but the way it'll fail, or the output it presents you, is the interesting part. I don't like the slowness of my tests, but that's not bother. So this is a failing unquote assertion, and the cool part is what you see here. It's not only saying expected true but is false, or expected equal but are not equal. It's actually evaluating the statement in between these weird at signs. This is a quoted expression. We call it a quoted expression in F#, but pay that no mind. The trick is it evaluates that expression step by step. So if a test fails, you can somewhat follow along with what is happening. So this allows me to write a little bit more complex tests than I would typically do in a C# code base, just because I have this pre-evaluation when things go wrong, and it prints it into the window. So it's a really cool way to test your code. You can even use it in C# code. I think I haven't tried it myself, but probably you can use unquote to test C# as well. So let's write this test. I'm thinking, or I'm doubting, should I write everything in between these unquote things, or can I do a bit of, can I do the arrange and the act step before the actual test or the actual assertion? Let's do it inside, see what this gives us. Also, fun fact, Visual Studio 22, the one that released this week, they actually promote using Fantomas for F# development. And Fantomas is an extension, F# specific extension, but it's basically prettier, or a formatter for F# code. So I have it configured that every time I save a file, so for example, if I save, it formats the code. This did nothing. There we go. So whenever I save, I get nicely formatted code, and you don't have to think about it while programming. That's a nice touch. Takes a bit of the cognitive load from my brain. So we were writing this test. Let's just parse it. Groovy parse contents. And the contents are in this thing. And let's just write an assertion. This should fail. I was thinking, can I run this in a REPL instead of always having to run tests, wait for a build? And yes, you can run this in a REPL. I'll quickly show you. But first, let's look at the failure. So we are parsing, it's inlining this entire string, so that's a bit much. Couldn't parse row 2. That is interesting. Expected 15 columns, got 1. Could it be this new line? But before I do that, let me quickly... Sorry, got some notifications. Let me quickly run this in a REPL instead. Yeah, let's run this in a REPL instead. So let's load... actually, this is just fine. We load like the Groovy file containing our parser. Let's quickly grab these contents. Just gonna paste them here because this sandbox.fsx file is just a temporary What's the green squiggly? That is not a valid file name. You are very right, but I don't want it to be a file name. I don't understand what's happening here. Huh? Is this Visual Studio not being able to follow along? Looks like it. Wow. Let's try to parse contents like we were doing in a test. And let's parse the actual contents instead of a file path. So let's see what this gives us. This should give us the same error. No, it does not, because I removed the new line. Okay. Wow, it's still early. Let's blame it on the hour of day, sure. Let's hopefully get a failure indicating that we expect an empty list of games, but actually it contains a game. Yes, it contains a game called Darksiders 3, and it is in my plate shelf. Let's look at the CSV, and that is correct. So it's not really test-driven development, it's more, or the way I developed the code in the previous session is a REPL-driven. So I use the F# interactive thing a bit more than I... So my point is, I don't write that many tests before I write code when I'm exploring stuff in F#. This feels much more natural to me. In C# is the other way around. I almost always start from tests, but that's because by now I know ASP.NET by heart. I know how to structure and design my code, so there it's from the flicker of a wrist. In F#, I have to think and fiddle a lot before I get things to compile, so that's why. I think this is okay enough. It's not the most exhaustive test, and I don't think our coverage will cover every path, because we only check for one type of shelf, and there's different types. There's played, playing, backlog, wishlist. And we could do that as well, but you get the idea. Let's move on to the next part. Groovy parsing text. Plural, it's a bit of a lie, but nobody will notice. Okay, let's do something more interesting now. Let us do some web scraping. So next step in my app would be to, for every game in my plate shelf, look up the average playtime. And it's interesting because this website I'm planning on using does not have an API. So if you look at what happens behind the scenes, or at least they have no officially documented API, and they also don't have like an internal API their website itself uses. If you look at what happens when you load a page on this website, it's, I don't know what it is, PHP, I don't know, but it's returning me the full HTML already. There's no API exposing data. So it would be interesting to, or interesting, this makes it necessary to, if we want to use the service without DDoSing it, but if you want to use this service, we'll have to do the requests, which will return a web page, and we'll have to scrape that web page a bit. And I want to do that just for fun. I promise I won't denial of service attack this website. So yeah, how do we go about that? I did some playing around last night, and we could use a page for the specific game, but then we would have to look up the ID of the game beforehand. So that would take 2 trips, one to figure out the ID from the name, and then a second one to request the game's page based on the ID. But I noticed while browsing that if you search for a game, for example, Darksiders 3, the one we had in our test a second ago, these search results that get returned, they also contain the average hours played. So if we can just do this search and scrape the search results, that's good enough. We don't have to do a second step going to the page of the game itself. So let's quickly grab the HTTP request that goes over the wire for this search. So how long to beat.com? Let's go back to the homepage first. There we go. Okay, let's get rid of everything and let's search for Darksiders 3. There we go. There's an HTTP request firing off, and it returns the full HTML, and it contains multiple hits, but it also contains the game we're looking for, and it contains the playtime, or the average playtime. This is all we need for our little app. So let's grab this HTTP request. You can use multiple approaches. There's node fetch, there is PowerShell, there is curl. I have used curl in the past, but let's use PowerShell just because that's the thing I had to use last week at work and it's freshest in my head. So let's copy paste this request. Jesus, that's a big request. I don't think everything we see here is necessary, but let's run this HTTP request in PowerShell, and yes, we get the same result. We get the HTML containing the thing we're interested in. So let's see what is actually really needed and what is fun or just for fun. So let's remove all the headers. We're still getting the result. Cool. Does the content type actually matter? Nope. Cool. That can go. The cookies, are they necessary? Nope. We still get it. Cool. User agent. I know for a fact that that is necessary because I had some problems yesterday, and we don't see it here because when PowerShell does an HTTP request, it actually adds a user agent header by itself. And it took me an hour yesterday to figure out what was going wrong. But yes, user agent is necessary. So we just do a post to URL, and we need to provide the user agent, and in the body we have these look like some URL encoded form values. So we have a query string. Does actually all this stuff really matter? Can we get rid of it? So just a query string, would that be enough? No, we get a not found. Okay. Randomize is 0. That's a... Why would you randomize search results? Never mind. So now we have an idea of the HTTP request we want to perform without all the unnecessary cruft and the cookies and stuff. We don't need that. So let's try it out. When I'm trying out stuff in F#, I use the REPL, as I said before. So let's drop into a REPL. And let's try to perform the HTTP request. You can use web clients. Is it a web client? You can use the C# clients or the ASP.NET stuff. Or the .NET stuff. It is not related to web framework actually. But for F#, you have some wrappers around it and they work better when writing F# code. They are in the f#.data package. It's the same nugget as where those CSV parsing type provider things came from. And I think they're called HTTP. No? f#.data HTTP. Yes. So you can just do a request and an async request. For the REPL, let's just do a synchronous call. And once we have everything working, we'll do a redesign towards an asynchronous design so that we can run multiple requests in parallel instead of doing every game in sequence. But first, synchronous. So let's do a request string. What's the difference? Request returns an HTTP response. Request string returns a string. Let's just do request first. It needs a URL, a query. We can provide headers. We can provide the HTTP method. Cool. Let me grab the PowerShell or the browser window so we know what to do. Let's put those next to each other. Cool. So URL, that is definitely needed. And that's the same URL every time. Paging. I mean, is this part necessary? No. Okay, let's keep it like this then. So probably we need to provide method as well. HTTP method. It's a post. What else? It's a post, and we need to provide the body and the user agent. User agent is where do you put the user agent in an HTTP request? In the headers? Let's look that up quickly. For everything web related, I use the Mozilla or the MDN. It's the developer wiki page basically from Mozilla, and it's really good for anything web related. User agent request header. So it's a header in the HTTP request. Let's plop that in there. And if you look at the signature for headers in this F# wrapper, it's just a sequence of string tuples. So let's build our headers. It's a sequence, so a list is a sequence. Let's make it a list of tuples. And it probably is a key called user agent and a value called whatever. Does it matter which user agent we use? Let's use scraper. That works. So we are even announcing ourselves to the website. We're scraping it. So we have user agent in the headers. We do perform the post. All we need is the body. And the body is form values. So it's just a value this is that, value this is that. Let's copy that over. How do we feed it a body? I'm not seeing it. Oh, there we go. Body is an HTTP request body. Okay. It's a discriminated union, so it can be different things. And it's either a text request or form values. Let's just try form values first. And this takes a sequence of string tuples again. So we can use the same thing we used for the headers. And let's just copy paste the entire thing in there. Yeah, let's copy paste the entire thing in there. I'm just gonna do this. So first form value is the query string, and that should be Darksiders 3. Second is something called T. No idea what I mean by that. To separate elements in a list, you have to use a semicolon, not a comma. There's probably a way to do this with some search replace magic. But let's keep it chill. Let's keep it simple. We're all halfway already, so. Forgetting about some parentheses. They're not really necessary. They're optional, but let's put them in just in case. I'm already regretting my decision about not using a... I think something went wrong here. Plat is an empty. Okay, I'm just gonna ignore that. If things don't blow up, I'm just gonna ignore that one. Plot, what would plat mean? I have no idea. Length, min length, MVV, blah, 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 blah. They all are not used. This is the first one that's still used. Randomize. This should compile. No, it's not. Because we have not put these parentheses up front. Unmatched. We have a comma instead of semicolon. And I'm missing opening brace. Oh, this was a very bad idea. There we go. So formatting takes care of things. There we go. Let's see if this works. Of course, headers is not defined. When you use a REPL, you have to make sure you have like sent the latest version of code in there, or you will get weird results you don't expect. We are receiving an HTTP 200 response, so probably we got something back. Let's see what we get back. That is not what I meant to do. That is what I meant to do. What's in this response? It looks like HTML. No result. For Darksiders, probably we don't have to encode. That's an interesting thing to know. So it can just be the plain text version of the title. That looks better. It's wrapped inside some HTTP response body type. And it's the text case. Let's quickly extract that. F#.data.http response body.text t. And if we... Sorry? Response body, HTTP response body dot text. If you do this, you extract the actual value, so you get rid of the wrapping type. If you receive something else than text back from this website, this will throw a runtime exception, so it's not something you want to do in production code, but just for debugging, sure, why not? Or for exploring. There we go, we have HTML, and this looks like the correct HTML. We have the game, and somewhere deep down below we have the hours played, so we're almost there. I'm thinking, should we dig deeper in this part and parse this HTML, or should we move this HTTP request thing to production code instead of this REPL we're playing around in? if we put it in production code, it means we have to think about a return type. Just a string? No. Or maybe we can keep it a string. That way, when we write tests, we have the HTTP part separate and the parsing part separate, and we can invest more heavily in testing parsing instead of performing HTTP requests, because we expect, no, the only way to test HTTP requests is by performing actual HTTP requests, and that's not something I do in my unit test or my fast test suites standard. It's something I do in another test suite containing integration tests or slower tests. So I just convinced myself, let's move this to production code. So it's just HTTP request. We have to give it a game title, and we get a string back containing the raw HTML. And maybe let's play around with it by then and see what the website returns when we provided a game it doesn't know about, like a typo in this game name or something like that. We can do that here. So before moving this to production code, let's clean it up first. Let's wrap it in a function. Let's get HTML for a game title. I'm calling it get HTML and not get how long to beat or whatever, because I'm going to move this into a module how long to beat. So we need, that name doesn't have to be there. Or let's put it in here for now and pull it back out once we move this. So get LHLTB HTML and a title should return a string containing the HTML we receive back again. And this game title has to be the argument right here. So this should do the same thing. And it is doing the same thing. Cool. Let's provide it something it doesn't know about. Let's look. Darksiders 4. I don't think that exists. It does not. And that's actually returning HTML as well. So no HTTP response 404 or nothing. It's just clean HTML saying Darksiders 2. Interesting. Let's let's look up something totally different. Lol whipped. This is giving me HTML as well, saying no results for blah blah blah. That's an interesting thing to keep track of. So when we don't know the game and we have no relevant results, we get this, and otherwise we get a blob of HTML containing what we're interested in. So I don't think we need to wrap the return type in anything special just yet. I was thinking about maybe using a result type or an option or something to signify the fact that we don't always get HTML back, but actually we do get HTML back every time. Up until now, we haven't found a way to receive something other than HTML. Probably when the site is down, we will, but let's not worry about that. So this looks good enough. This union case will totally break if we receive something else, but let's not worry about that. So this can move to production. Let's add a new file to add a module. Let's call this how long to beat. If it wants to, at least. And let's add this function over there. I'm seeing a lot of F# data, blah, blah, blah. Let's just open that DLL. I don't know if I have tooling that automatically does this. I installed ReSharper, but ReSharper and F# are not the best of friends. Or they live together nicely, but they don't do a lot for each other. This value is not a function and cannot apply. It feels like the formatter is messing with me. Let's just quickly do this. What's the difference with 2 seconds ago? Sorry? So I have this doesn't compile. I have this does compile. I don't see the difference. Never mind. So we have how long to beat, get HTML. Let's get rid of this how to beat in there. Good enough. So this can go as well, and we can do load in the new module. Interesting. I have no completion on file names when I'm in a FSX file. That's a shame. Incomplete parameters. Oh, the compiler warning is actually leaking through in where I use it. I haven't seen that before. So this should work. That green squiggly line is making my eyes bleed, so I'm gonna clean it up in just a second. Yep, that seems to work. Let's try with a game we know exists. Yep. That looks good. Let's fix the green squiggly. How will we fix it? Yeah, let's just crash. Let's not bother with a result type or something like that. So let's just explicitly pattern match. So match on the response is body, and if it is text, we can return the text, and otherwise we're gonna fail not that gracefully. So for an actual production scenario, you might be looking at result types or something, or even exceptions, but not a pattern match exception. That's a bit, or maybe you could, but I don't typically do that. But now we're just gonna crash. So if we receive text, an HTTP response containing text, we just return the text in there. And in every other case, we just crash hard, throw an exception, saying that we don't know what to do with it. Not the purest of functions, but suits our purposes. Cool, that seems to work. Everything's cleaned up. This looks like a great place to commit. We can fetch HTML from the how long to beat website. Don't need to write any tests for that. It's HTTP. Don't want to waste my time on that. It works for now. So next step would be to parse the actual HTML and to extract the playtime from that. Do we have time to do that? 50 minutes in? Yeah, we can do that. I'm hoping it won't take too long. HTML parsing can be a somewhat pain in the ass though. A real pain in the behind. Yeah, but let's still go. So how would we go about parsing this HTML? Should we test drive this? Yeah, maybe we can test drive this. Let's grab a case where we know it returns some valid HTML. Results found. So HTML containing some actual results. And let's quickly open up another editor so we can escape those quotes just like we did in the CSV. I use Visual Studio Code a lot for F# development too. It has great support actually. But because .NET 6 released and Visual Studio released, and at work I use Visual Studio mostly. That's why I'm also using it in this stream. Let's get rid of the opening quote. There's a lot of white space. This is some really funky HTML actually. But that is not a problem. Replace a single double quote with an escaped double quote. There we go. Let's copy it in its entirety and let's dump it in here. That's a lot. Okay, but we have IDEs for this. Can I minimize? I can minimize. Cool. So yeah, let's just try it. Parsing. How long to beat responses with actual results, and then we'll write a another test for the we haven't found anything case. Yeah, sure, let's go that way. So in an ideal world, we would have a function that we give some HTML or a string containing some HTML, and we get back something representing the playtime. Yeah, so I said we're gonna do this test driven, but actually when I write F#, I do something else. It's called type driven. I think about the method signatures and the types first, and that typically works better by declaring the types instead of trying to write the test first and the assertion first like I would do in C# code. So let's show you what I mean. Usually I would do like let's open the module we're testing. How long to beat? And let's say we want to, or actually we don't need to open it. We can just prefix everything. So say we want to do a how long to beat dot parse. The more I'm doing this, the more it feels like different from the way I usually write F# code. I always use a REPL or the interactive window actually. I don't test drive my F# code all that much. Can we give it a try? If resharper will help me generate this function, then we will give it a try. If it does not, I will forget it. What will we get back? Maybe something containing the title we selected, or a list containing all these search results. Yes, let's return a list containing all these search results, and they contain the title and the playtimes, or at least one of those playtimes. So title, whatever, start titles 3, and playtime. Let's just keep it a decimal. We might have to want to structure this. But now, if this was C# code, I could just press Alt Enter, and resharper would generate everything for me. Alt Enter is something else in F#. It sends code to the REPL, so I have No idea if this will actually work. This is what I meant with ReSharper and Visual Studio, or ReSharper and F#. They coexist, but they're not the best of friends. You have no support. There's no like generate method, refactoring, or at least there didn't used to be. Let's see, I did something accidentally. Yeah, you can't do anything. So get this test-driven part. I prefer working type-driven and REPL-driven. So let's comment this out for a while. Let's grab this HTML, go to REPL. I'm just gonna dump it here. And let's just play around with it. How do we parse HTML? How do we parse HTML? You have a type provider, like we did with the CSV parsing, but the HTML provider works best if you have tables in your HTML. It doesn't work that good with random websites. Let's look at the documentation. This is not the documentation, this is the API. Description, there we go. It reads HTML tables files in a statically typed way. And we don't really have tables, we have divs containing divs containing divs. So let's not use a type provider, but I think F#.data also has some HTML parsing. I always mistype F#. HTML document, is that the one? I think this has a parse as well. Yeah, so this can parse HTML. Let's just try to parse the thing. I hope it's valid HTML, because if it's not even valid HTML we get back, it's gonna be interesting. Okay, it seems to parse it just fine. That's a relief. Let's take a look at this HTML. Can we format it? No? Format? Okay, just took a while. So what are we getting back? We found this many games, cool. We have an unordered list. And every list item is one of the games or one of the search results. So maybe let's parse the HTML, pull out a list, and for every list item, let's parse a search result. And it contains a title and playtime. Yeah, that sounds like a cool strategy. So let's first try to parse out or dig into the HTML and get the unordered list, the UL element. How do you do that? This thing has no methods. Okay, probably F#. Let's open F#.data first. We don't have to fully prefix everything we do with F#.data. There we go. Have we sent it to the REPL yet? Yes. Okay. So now it should work without the prefix. Yes. And let's use a pipe. Do we have functions here? Yes, we do. So we have descendants named, elements named. We don't own the backend, so let's do the parsing a bit defensively. Named finds all of the descendant nodes of this document that match the given set of names. What do they mean with names? Is it like the attribute name equals, or is it UL? Let's try it. Recurse on match. I don't think we need to recurse. What's another argument? The names is a sequence of strings, so let's try to dig in and grab all the unordered lists. It seems to work. I'm thinking maybe we can go a step further and just extract the list items themselves. How many do we get back? free. So I think we can just extract them like this, get every list item, and then continue there. So now we have a list item for per usual, and we would like to grab the title, and the playtimes. These playtimes are a bit, it's a shame, they're like not really structured in HTML. It's just a div with several divs. There's no specific class for every different playtime, so we'll have to do something index based, but index based is not the end of the world. Let's try to parse the title first. Let's grab it from the A. There's multiple A's. Let's grab it from, let's first dig into the HTML to grab this div, search list details, and let's then parse the title or the contents in here and playtime. So first things first, for every list item we find, let's grab the div with the search list details class. Yes. So for every list item, we have to do something, and that sounds like a map. So let's sequence dot map, and let's write a function search result. And what is that? An HTML node. And return whatever. So parse search result. This should work. Yes, let's line up. Type inference needs some help, so just let's do something. And to see what we're doing, let's evaluate the sequence to a list, so it's not lazy, it's eager execution. There we go. So types line up. Now we should be able to proceed. And for node, this has methods, so we can use the C# way of doing node dot, or we can probably do the F# way of doing HTML node dot. And we'll have the same functions. Yes, it does. Okay. What are we looking for? Something with a class like this. We have class find descendants with a predicate. Actually, that's cool. So we don't have to recurse on match. And the predicate is a function that takes the node, which is one of the descendants, and it has to return a bool. Cool. So a function that takes a node and has to return a bool. Why are there squiggly lines here? Tabs are not allowed in F# code. What? Since when are tabs not allowed? I've been using tabs all my life. Oh, you're right. It's actually using spaces, Fantomas. I'm not gonna worry about it. So this is a function that takes the div, a list item div, and we'll have to filter out enough to get the title. And it has to be something with a class, so has class, and it has to have this class. So now we pick out that class probably. Yep. Let's do list that as well for just for now, so we can see what we're doing. And it's giving me grief again. I don't know if I like this tab versus spaces argument I'm having with Fantomas, but okay. It's probably a setting I can change. Yes, we have the divs search list details. Okay, so we have the correct div. Let's now dig into that div to extract the title in the hyperlink in the A tag. It's a single A tag we have? Yes. So let's just look up that single A tag and grab the inner text. So this is the search list details. Let's just call it by that name. And let's now grab the A. Now we have the A element. It's again with the tabs. Did I miss a memo? Are tabs bad practice in F#? Oh, let's actually look that up because that's interesting. What tabs are not allowed? Is it because we're in a REPL? Probably the extension has a convert tabs to spaces thing. It has a lot of options. Something tabs, something spaces. Yeah, you can give the number of spaces, but you can't. That's interesting. Okay then, never mind. HTML node list is not a... Oh yeah, we can have multiple A elements, but we actually know there is a single one. Sequence of strings. Okay. A sequence instead of a single string. And then the false, the argument has to be there. Cool. Okay. I'm getting sidetracked for a second. Does it have to be multiple? Yes. Okay, then let's just do the same again. Let's just assume we always have valid HTML, and let's just assume it always has a single A element. And let's just assume that tabs don't exist. There we go. There we go. Now we should grab the actual title. That looks cool. So that's the title. Now to parse the playtimes. Let's quickly print out what we had. Oh no, we have the HTML somewhere else. There we go. So now we're working on the level of this div. We just extracted this A to grab the title, and now we should grab these. Let's just grab everything with a how will we do this? Time 100. That sounds like it could be a color. Yeah, they differ depending on how long the actual time is, so that's maybe not a good thing. Maybe we can dig in just on div structure alone, or we can use search list tidbit and hope that's somewhat stable, or that remains somewhat stable. Whenever you do web scraping, you know your software will break or your code will break whenever the website changes, so it's a risk you have to live with. So yes, let's grab every div with this class, the search list tidbit class, and keep only the even ones, or we'll figure that out in a second. So this is the title. And again, oh, this tabs versus spaces thing. Did I not type spaces before? Was this all on Thomas doing its magic? Interesting. Anywho, we grabbed the title, let's grab the playtimes. So let's get all the divs. From the search list details. Why can I not? Oh, it's because of it. Why can I not access this variable? What's going on? Oh, it's because there's a tab. This is something else. Yesterday I did some F# coding and this was not I was not tripping up over tabs and spaces. So I don't know what changed in the last 5 minutes, but I don't like it. Anyway, let's do a query again on class. So actually it's literally this filter, but on a different class name. And the class name is search list tidbit. And that should contain something like 6 divs. And it's a sequence. Oh. And you can't use tabs. This is gonna trip me up until the end of days. I could also just put it on the end and allow my formatter to do it, but yeah, okay. We could parse all the playtimes, or we could just grab the one I'm most interested in, which is the main plus extra, because that's the way I like to play games. I don't just focus on the main story. I don't want to be a 100% completionist. I just want to do main quest and side quests. So let's just grab this one, and that is the 1, 2, 3, 4th div. So let's just cheat a bit here. Let's just grab the 4th item. It's 0 based, probably the index. Yeah. So this should give me 4 hours. 40 hours, sorry. Is it 4? Was I seeing cross-eyed? So we would like to have 18.5, 1.5, and 4. Yeah, that was correct. Cool. Oh. And let's just extract the inner text again. inner text. There we go. And tabs versus spaces. Sorry for this. I'll never get used to it. There we go. It's a weird ass string right now instead of an actual number, but we're getting very close to what we want. So let's now just parse that playtime as 4 space hours space 18, and there's a really weird sign that is probably a half. 1 divided by 2. Okay. So let's parse that out. Let's write a new function for that. Playtime. And let's have it return a number. A decimal number, because you can have half an hour. So that's the playtime text, and we want to return the parse playtime. So we should do something with this text. Let's maybe write a quick test for it while we're writing the function. So this should be 18.5 for the first. There we go. And let's copy this raw text and put it in here. It does not know about tests. It should, if we open up unquote. There we go. Now we should be able to run this test. It fails because we haven't implemented it. Cool. Text is a string. Let's make that explicit. Let's make the type explicit. There we go. How will we parse this string? Let's first grab the numeric part. So let's do a text dot split based on a string. I think we can do a string. Can you split on a raw string? Separator string. Yes, you can. An option. Oh, this is better than what I did before. You used to provide like a second argument, string split options, and you need to provide an array instead of a single string. I like this API. It's a bit cleaner. So let's split on this thing, ours, with a trailing space for some reason. Don't really need to worry about that trailing space. We need to worry about the space before it. And this should have a first element. Now I press tab. Oh no. Auto fixed my tab into a space. Cool. I don't think we need to do the dot when we index in F#6. Cool. It's getting a little bit cleaner. It's no major changes we've seen today, but F# is getting a little bit cleaner every release. Let's write a simpler test first. Just 18 hours. Let's forget about edge cases just for now, and let's just do system.decimal.parse. There we go. And that it's not really. It looks like Fantomas does not know about the new indexing yet. So okay, let's keep the dot in there. Yeah, this works. And 18.5 should not work. Nope. So let's do a naive thing, and let's just replace the half. It's not really the cleanest way. Yeah, actually it's not that bad. So let's replace this character we encounter with 0.5. Yes, and so this should also evaluate to 18.5. Cool, that works. I'm gonna rip my tests and put them below. We'll move them to actual unit tests later. But for now, this seems to work. Let's parse playtime. Why? Is it because I tapped again? Jeez Louise. Yes. I think we're there. I think we can parse the HTML now. There we go. Let's quickly declare a type to wrap our parsed results in. And that will be it. Type search result is something with a title and just one playtime. Type decimal. There we go. And let's return it. So title is the title we parsed, and the playtime is the playtime we parsed. And it should be closing. There we go. Cool. Does this work? It appears to work. So given a string, we can parse it into a list of search results. That sounds amazing. Let's wrap that in a top level function. Oh. Sorry for dozing off. There's a duplicate definition. You are absolutely correct. I was dozing off because I was thinking there's this something is not symmetric. The first line is HTML document.parse, and I don't like it because everything else is piped. But then I was thinking actually we can make everything piped, so it reads in a more consistent way. There we go. Yeah, so we have a top level function that gets HTML and returns a list of search results. Let's explicitly type that to make it super clear. And this uses another function called parse search result. Given an HTML node, it does a lot of things. It digs into the HTML, grabs the title, digs into the HTML again to parse the playtime using a different function. A lot of things can go wrong here, but let's worry about that when we get there. And we return a type representing whatever we parsed. I'm happy with what I'm seeing here. Let's move this to production, or to production code. So everything here is actually how long to beat parsing. So this is how long to beat HTTP requests, and this is parsing. Let's just drop it in there. Parse playtime, I'm gonna keep that as a public function because that might be interesting to test in isolation later. We already wrote some tests, so that already indicates that it's interesting enough to take a look at on itself. This one I don't care about. Let's make that private. And this is the top level function. This one we definitely need to expose. So the type also needs to be exposed, yes. So let's drop back into the REPL. This can go away, and we should be able to open how long to beat and use how long to beat. Hello. Yep. There should be automatic refactorings for this. This feels very artisanal. So if we load a new version of that file, we should be able to parse the search result just as we were doing. Yes, and those tests should work. They do work. Maybe let's, as the final thing for today, because we've already been coding for 1.5 hours straight, let's convert these ad hoc REPL things to actual unit tests. And let's write a quick bigger scale unit test for the entire thing. So let's drop into our tests, and yes, we were actually doing this. So it's already there. And now we have actual production code to test. So we should have a parse search result. And before I forget, I copied the playtime tests. Those 2 lines, yes. Everything else can go. No, this is the thing I get. Yep. Sorry for the confusion, but here we go. So parse search result, and this is the dummy HTML. Put it in there, minimize it, forget about it. Let's rename that to HTML. So when we parse the HTML, we should get 3 results back. Should be able to run this code in the... It seems to work. That's not supposed to work, right? Oh, there we go, 12. So we're actually... This is what we get, and we expect the empty list, which is obviously wrong. This is what we actually receive. So we have Darksiders 3 for 18.5 hours. We have Darksiders 3, the Crucible DLC, 1.5 hours, and we have Darksiders 3, Keepers of the Void DLC for 4 hours. Thanks for the format. Quickly compile and run our tests. And the compiling takes a very long time. Wow. Everything's green. Let's quickly write a test for the playtime because it's a bit finicky. And I'm just gonna grab these 2 tests we wrote in the REPL and put them here. It's 2 assertions per test. I don't care. That are heuristics, not hard rules. I think that's enough for today. So what did we do today? Sorry. We basically wrote an HTML parser and did an HTTP request so we could find playtimes given a game's title. And we wrote some tests for it. They are really slow. Why are my tests very slow? Where are my times? Whoa. 2 seconds. 2 seconds to run like 4 unit tests. That's really long. Is it because of the unquote thing? Is it because of the big string? I don't know. But for a small project like this, I don't really worry too much. We have Groovy parsing tests. We have how long to beat API tests. And we have this using unquote assertions. This can go because that was an example. I think this is a good stable point to check in our code and enjoy a nice coffee. Job well done. So check in. we can parse HL2B search results. Yay. Commit, push, push. Yes, okay. And there you go. This was live coding F#. I think we are 70% of the way there. Next time we're gonna combine the search or the Groovy parse results and the how long to beat API, and we'll probably make this how long to beat HTTP call asynchronous, so we can run it in parallel, run several requests in parallel, so we don't have to wait 300, or I don't know how big my play library is, but yeah, sounds fun. See you next time. Ciao.